In this video, we'll go over solving quadratic equations part 3, specifically solving quadratic equations using the square root property and solving quadratic equations by using the quadratic formula. Recall the standard form of a quadratic equation is ax squared plus bx plus c equals 0. These must equal 0 in order for it to be an equation, but we'll see except for when we're dealing with the square root property. Is an exception. And then a is in front of x squared, b is in front of x, and c is the constant. Example 1. So these are examples solving quadratic equations using the square root property. When you have x squared just equal to a number is when this property applies. For the first example, x squared equals 25. So remember that whenever we're solving an equation, we're finding the value or values of the variable that make the equation true. What number squared is equal to 25? That would be 5 and also negative 5. Okay, a couple things to remember here. 5 squared is 25. Negative 5 squared is also 25. And with quadratic equations, we usually have two answers. If we were to solve this using the square root property, we would take the square root of both sides and make sure you include the plus or minus. We would have then x is equal to the square root of 25 is 5, and we'd have negative 5. Now the software doesn't have a plus or minus button, so you would need to write both answers, 5 and negative 5. Part B, x squared equals 41. So if we're solving using the square root property, we have x squared equals to some number here. We would take the square root of both sides. In this case, 41 is a prime number. So it's not a perfect square, and we can't simplify it any farther. So in this case, x would be equal to the square root of 41 and negative square root of 41. And that's all you would have to do with your answer. You could just leave it like that. Example 2, solve for x. X squared equals 48. So solve using the square root property. We're going to take the square root of both sides and put the plus or minus there. Now notice on the right-hand side, we have the square root of 48. So I'm going to do an aside here and talk about how to simplify the square root of 48. What I would do is I would list the factors of 48 and see if there's any perfect square factors. So for 48, we have 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. You could choose any of these that you want, and then you would have to go from there. I'm going to choose 3 and 16 because 3 is the prime number. I know it can't factor, or there's nothing that goes into it, and 16 is a perfect square. So this could be rewritten as the square root of 16 times the square root of 3. Since the square root of 16 is 4, that stays on the outside, and it's still being multiplied by square root of 3 because that couldn't simplify it any farther. Sorry, my computer just... Anyway, that can't simplify any farther. So this would become x equal to positive 4 square root 3, negative 4 square root 3. If you were to choose, and let me box this off, something like square root of 48 is equal to, let's do 4 times 12. And let me pick a different color. If you did the square root of 48 is equal to the square root of 4 times square root of 12, you would have to simplify this as much as possible. So yes, the square root of 4 is 2, but the square root of 12 contains perfect square factors in it, 4 and 3. So you would have to break down square root of 12 even farther. So we'd still have the 2. 12 breaks down into 4 and 3. The square root of 4 is 2. So you would still end at 4 square root of 3, but in multiple steps. So there's a way to be strategic about this to maybe simplify the process for you. Part B, x squared equals negative 81. 81 is a perfect square. However, when we're looking for a number squared, is it ever going to equal a negative? You can't square something and get a negative. You could try 9. That's 81. You could try negative 9 squared, which is still 81. So this one has no solution, or no real solution. Using the quadratic formula, so again, ax squared plus bx plus c equals 0. You use the quadratic formula when no other methods of factoring work. okay? Or no other methods such as factoring or the square root property work, and the quadratic formula is in a box here. You do need to have this memorized. A, B, and C come from the standard form of the quadratic equation, ax squared plus bx plus c. There is a song, you may have heard it. It's the quadratic formula put to Pop Goes the Weasel. Music is a very helpful tool to memorize. I don't play it because once you hear it, you can't unhear it, so I'll let you make the decision if that's something you want to look up. Example 1, solve for x. So 2x squared minus 5x minus 1. Since we're in the quadratic formula section, this is probably how we're going to solve it. But you should try the AC method, the slip and slide, or the X, whatever one you choose to use, to make sure that something doesn't factor. When using the quadratic formula, I'm going to rewrite the formula at the top, negative b, or opposite of b, plus or minus the square root of b squared minus 4ac, whole thing divided by 2a. So we need to see what a, b, and c are. In this case, a is 2, b is negative 5, and c is negative 1. So we take these values and we plug them into the formula. X is equal to negative b plus or minus the square root of b squared. Oops, let me make that a little bit nicer. Squared minus 4 times a times c, all divided by 2 times a. So the black writing is what's part of the formula, and the blue writing is me filling in a, b, and c. So now we do what we can to simplify this. So we have x is equal to negative 5, or negative 1 times negative 5 is just positive 5. We have plus or minus square root of negative 5 squared is 25. Okay, and now minus 4 times a times c. There's a couple of different ways to read this. You could read it as negative 4 times 2 times negative 1, or if you keep the minus there, negative 4 times 2 is 8 times negative 1 is a negative 8, and minus a negative becomes a positive. All divided by 2 times 2 is 4. And so we keep going. So this would be 5 plus or minus the square root of 25 plus 8 is 33. All divided by 4. Okay. So you would have two answers. You would have 5 plus the square root of 33, all divided by 4, and 5 minus the square root of 33, all divided by 4. And you would have to write both of those separately in the software. Thank you for watching. If you have any additional questions, please feel free to reach out to me.